All right, everyone, welcome to the next talk this morning. We have 3 wonderful presentations about the toolkit for developers on Tezos. First up, we have John Newby from TZ Connect, who will walk you through a number of very interesting tools on the Tezos blockchain. Second, we will have Thomas from Functori. And then third, we will have Sergei from Baking Bad. Let's give a round of applause for John.
Thank you very much. So I want to talk today about a couple of tools that our team in Berlin have developed. One of them is an NFT minter called Peppermint, and another one is an indexer called Kipasa. And I want to introduce them because you've all been using them since you've been here. If you have interacted with the kiosk app, which I have a tablet to demonstrate. I was going to demonstrate with my phone, which unfortunately I've lost. I know it's not properly lost because I'm still connected to its hotspot, but it's somewhere around. So let's just make this a little bit more pretty to look at. So the history of Peppermint goes back to maybe the middle of last year when we had to send a big NFT drop for Blockhouse, and we were using PyTezos, and it was a nightmare and took about a day to get 50,000 NFTs sent. So we had to think about what the right thing to do was, and we alighted on Taquito as the SDK of choice. And we decided to write a bulk NFT sender, which was driven by a SQL database by Postgres. And the idea of it was simply that you instruct the database, you put a row into the database instructing an NFT to be sent, and Peppermint goes through all the rows in the database, assembling batches of NFTs, sends them out as fast as it can, and then waits for more NFTs to come in or for the block to be confirmed. So that it can do that. Obviously, this is not a super blockchain-y way of doing things. It's a very centralized way. The normal way might be to have a contract on chain, which is minting the NFTs. But for us, this way of doing it works very well because we get control over the process. We have really good reporting. We can resend things if we have to, and it doesn't require that the recipient necessarily have any Tez. So it's a really great way to onboard people onto the Tezos blockchain, particularly when it's in conjunction with something like the app here, where people open a Kukai wallet, they can scan a QR code, and then we can send them an NFT, and we can even send them some Tez, which is what we're doing right now. And so suddenly we've made a blockchain user from somebody who didn't have any blockchain exposure before. They don't have to go through a KYC process. They don't have to know anything. They don't have to think about key management because Kukai takes this problem away for them. And we just pushed them an NFT, and we've converted a non-blockchain user into a blockchain user. So the second part of what I want to introduce you to is Kipasa, which you can see beavering away here. We try to make the smallest tools that we can at TZ Connect because we're quite a small team and because we don't really want to indulge in too much feature bloat. So about a year ago, we started making a Kipasa, which is our indexer, which is not an indexer at all. Because what it does is it reads the Michelson storage format of a contract, and it generates SQL statements which create tables for it, and then it reads the storage as it's updated and turns that into SQL update statements. So Postgres does our indexing. Kipasa is just a compiler which compiles Michelson into SQL. So the magic with them really is that now we have everything in a Postgres database, which again, it's like the most Web 2-y of Web 3 solutions, but it means that we have like total insight into what we're doing. We can look at the contract storage. And we can see all of the current state of it, or go back in history. We can look at our operations here, and we can even ask questions like, we can say staff role. We can see all the things which failed. We can then say, so sometimes we don't get a decent response back from the node about whether our transaction was included in the blockchain, and we can see that these ones are unknown, but we can say select star and da, 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 da. Mm-hmm. And so we can see that we can do the select, which took me a little bit long to make, apologies, where we can say, if the state's unknown, do you find to address in the ledger of the contract? And we can see, in fact, they were all in the ledger, and we have total management of the state of our contract and what's happening inside it. So Peppermint is driven by a really simple config file in which we simply put the private key of the account that we're sending with. So obviously the machine it's running on has to be locked up nice and safe. We have the node that we're going to and database set up in the contract. So this one is left over from the We Are Developers in Berlin, at which we did a coffee promotion, and we've just repurposed it to be the merch store here. Kipasa just runs from a very simple end file. And a very simple config file. And you can run all of this stuff on a machine with one CPU and 2 gigs of memory in this case, and they run super happily. So this was just a super quick introduction to these two tools which we made and which we find really useful as building blocks for projects that we do. I wonder whether there's any questions. Yeah, please.
I was just wondering, where do you get your data from?
In terms of like the index, so where does it get the data from that it indexes?
Yes.
Yeah, so we pull the node every second looking for a new block, and then we look in that for any operations on contracts that we are interested in. and then we push them, we convert them to SQL and insert them in the database. And then, like, relatively frequently, we have to roll back because there's a little fork, but then we just rewrite the block.
Ok, donc so no TezDev API or...
Sorry, do we use like TZKT or no? No. So the reason that the impetus for us building this, first of all, was that we were demoing something and we were using the Better Call Dev API, and Better Call Dev's wonderful, but at the exact moment that we were demoing, it went down, and there was nothing we could do about it. So the impetus was, we wanted to have something very tiny which did like one thing very well. So if we look at the database, we can see, let's see. Like, so we just make a schema for every contract that we index. If there are 10 contracts, there were 10 schemas, and then it has a table called storage. And then beyond that, we make like foreign key constraints for maps and big maps, and then we make derived tables for the live state of the contract. I would say like 99% of the time we only ever look at the live state of the contract because it tends to be the thing that you're interested in. But you can, in principle, you can just go back and look historically at everything that's ever happened.
Thank you.
Yeah.
How are you going to handle
roll-ups? This is one thing about like the way that we have the indexer. We only really care about the on-chain state. So anything that's written to the chain, we will index. But the rest of it, we don't. I think it's kind of orthogonal to Que Pasa. I haven't thought about it that much, but I think that like we sort of don't really care about them. They're outside of our remit. Cool.
All right, and with that, let's give a big round of applause for John. Next up, we have Thomas from Functori.
Hi, so I'm Thomas from Functori, and I'm really happy today to present Factory, which, so I put the title Smart Contract Development, so that will become apparent soon. So first of all, I want to present Functori, my company, the company I worked for. So we're a research and development company created in 2021 with experts in programming languages, especially OCaml, which makes Tezos a very natural choice. We have a background in formal verification, a lot of experience in blockchain technology. We've actually been contributing to the Tezos protocol. For example, Tenderbake and recent work on rollups we've contributed along with other teams. We also write and audit smart contracts. And we write tools for the Tezos community at large, so I'll be talking about a few of the tools that we develop. So I want to talk about the state of smart contract development on Tezos, and there's a lot of pros about smart contract development on Tezos. So for example, we have a very nice collection of high-level languages, many of which were presented in the TezDev event. So you all heard about Lego, SmartPy, Archetype, and I'm not mentioning some other ones as well. There's Scaml, I think. But if I'm forgetting any ones, it's just my fault. There's a nice sandbox, FlexTesa, which is very handy for doing tests. There's many different ways to test your smart contracts. So if you want to hack into the node, there's a testy, there's the mockup mode. There's also language-specific modes that you've seen in the previous days, yesterday. And there's even a Coq formalization of Michelson, which allows to do formal proofs about the behavior of smart contracts. So these are very nice pros. What I'm going to describe here is the state of smart contract development as I found it And it's not. I know that some of the problems I'm going to mention are mitigated in some of the systems, so it's not an attack on anyone. It's just a general comment about what it's like to write a smart contract, what it's been for me in the beginning. So first you write your smart contract in a high-level language, right? And then you compile it. Then you write some initial storage for it, so maybe in the high-level language, maybe in Michelson. You deploy your smart contract. You get a KT1, you copy it on the terminal. Then you write some parameter for one entry point. You call the entry point by pasting the KT1. Then you make a few calls to the entry point. You want to try them out. Then you realize you made a mistake in the previous call. OK. So you have to redo all the commands one by one. You have to originate again and then redo all the commands. You do this 10 times, and then you think, OK, maybe I'm going to write a script, because this is a bit bothering. And then you realize, OK, there's a bug in my smart contract, so I need to modify my smart contract. And then your script fails. Maybe it's a bash script. Usually you start with bash scripts. I'm looking at you, Mohamed. And then you don't know if is it because I changed some type in my contract? Is it because the balance is insufficient? Is it because of the smart contract logic? So of course you do a dichotomy to find out why did my script fail, and you parse a really long error message with some numbers of copies of the word failure in it. And so you write a whole lot of clever scripts to catch the various failure modes you have encountered. You use SED, all kinds of hackish tools, and you try to make your one contract interact with several other contracts, and this, of course, multiplies all the possibilities of errors. And then, of course, the smart contract is just the first step. You want to build a DApp, right? So you start writing an interface to visualize the state of your smart contract. So at this point, you have maybe two or three different versions of the interface of your contract. You have the contract, the backend, the visual interface. And anytime you're going to change anything in your smart contract, you're going to have to make all the changes in the backend and in the visual interface. Because otherwise it's going to break again. So some solutions to these problems have been emerging, and some have been presented right here. I think, in particular, the SmartPy ecosystem has really nice interface. We've been developing at Functori our own solution called Functori, which you can find on GitLab, and I'm going to present it. So here, first I want to talk about our design principles. So I put design principles of Functori. It's actually Factory, but it's also our design principles in general. So first, any code which can be automatically derived from the code of the contract should be generated, not written by a human. And errors are part of software development. Errors can be useful, and especially when you have strongly typed languages like OCaml, or to a lesser extent TypeScript, then you can actually get useful errors that will inform how you fix your problems. So if you rewrite a small part of your smart contract, okay, it's fine. It's going to break your scenario. It's going to break some things, but the errors you get are going to be meaningful, and it will be apparent what you need to modify. Like, I just added a field to this record. I need to add this field to the backend and to the visual interface with a nice typing error. And finally, it has to be easy to combine as many smart contracts as you want, wherever they may come from. Some may come from the blockchain, from the mainnet blockchain, from JakartaNet, IthacaNet. I'm not sure IthacaNet still exists. Or something you wrote. It can be written in any smart contract language. You should be able to write a scenario making all these contracts interact together. So this is a rough sketch of how Functori is designed. So Functori is a single entry point either from the Tezos blockchain or from a high-level smart contract language. And then it generates a whole bunch of things. So the two things that it does generate now is an OCaml SDK and a TypeScript SDK to interact with the contract. We're also working on future SDKs in other programming languages, namely Python and Java and maybe some others. Also, it generates an API to interact with the contract right out of the box. So this is still a work in progress. It also generates a custom and customizable crawler. So this is a fresh news. So we have our own crawler. So a crawler is like an indexer. John before talked about an indexer. So we have our own indexer called Crawlery. And so we generate a crawler for your smart contract, which is able to put all the events related to your smart contract inside the database. And we're also working on hooking dipped up into it, and we're open to any other indexers that may be out there that I may not be aware of. All this relies on the library, one of the tools that we developed, which is a bit of TZFunc, which is a bit the equivalent of Taquito, but in OCaml. So if you need to do stuff in OCaml with the Tezos blockchain, it's a very useful tool that I highly recommend. And of course, all the TypeScript code depends on Taquito, and we're really grateful to the Taquito team. Okay, so a lot of stuff is generated that some of you may have been writing by hand until now, and that we want the programmer not to have to think about. So this is an example of a TypeScript code generated by Functori from a contract on the blockchain. So it's not a high-level language. We don't know what high-level language this contract was written in. It comes from the blockchain. It's a Michelson file. And automatically, Functori will generate. So here you have the storage type. So it's apparently an FA2 contract. So you have a nice clean record with metadata, assets, and admin. Each of these types is actually defined. So admin has a pending admin, paused, and admin field. Assets has all these fields. And all this is for free. So all this is generated automatically for free. And the same is done in OCaml. Of course, this wouldn't be complete without a way to transition from this type we generated to the Michelson type, right? So we want to be able to encode this storage that we write in TypeScript into Michelson, and we don't have to write all the gory details of how it's encoded in Michelson. So this function will do that for us. It will encode our storage into a Michelson expression, and it will also generate a decoder, which will take a storage in Michelson and convert it into this type. Functori can also pull the actual storage of a contract on the blockchain and write it immediately as a TypeScript value. So this is from the FA2 that I pulled from the blockchain. This is its storage. So if you want to do a quick test, originate your contract with some storage, you can use the one that's actually on the blockchain, and or maybe modify it slightly. Maybe you want to change the admin from this to Alice or Bob or your own TZ1. We also generate a ready-to-use deployment function, so you can originate your contract using this function without having to think about the Michelson type once again, because this storage is not a Michelson value, it's the TypeScript type that I showed before. So as I said before, we use Taquito in a TypeScript interface, and another shout out to the Taquito developers. The code of the contract, the Michelson code of the contract, is automatically included in the deploy function, so you don't need to think about, oh, where did I download that Michelson file that I want to originate, which is sometimes also a pain. Yeah, and so that's deployment. Of course, it's not only about originating contracts. You also want to be able to call the entry points. So for every entry point, Functori generates a ready-to-use function which can call it. So for example, this is the mint entry point of the FA2 contract. So you just have to input a KT1 and a parameter in one of the generated types called mint. So once again, not a Michelson value, but a native TypeScript type with readable fields. And using this function, you can just call the entry point. And of course, if you're writing your FA2 and suddenly you change the type of the mint function, you will get an error actually, so if you've written a scenario where you call the mint entry points and you've put some parameter, and now you've changed the interface, you'll get an error, but it will be a clean, readable error. It will say, okay, I was expecting this type, and I got this type, and both types will be it will be immediately apparent why you had a mistake, and you can fix it immediately. Okay, and so using this, you can write scenarios. So once again, using Taquito. So write some initial storage, deploy it. And you can write this. You can start writing the scenario seconds after generating the interface from Functori. Yeah. So. Okay. I want to talk a bit about the more advanced features, and then about the future features. So. We have in OCaml a way to generate random elements of any types, any of the types generated by Functori. So if you want to do quick tests, or if you want to do, you want to check that the logic of your smart contract by throwing random calls of some entry point, you can do that. And we're also working on that in TypeScript. You can customize the kind of randomness that you want, which could be useful. You can easily access big map elements, which is also something that's sometimes a bit painful, because big maps are just, as you saw in the storage before, big maps are just an integer, 52,863, and if you want to actually look at the elements in there, it's not immediate, so we have helper functions for that. You can generate identities on the fly, a bit as I think Ganache does that as well, and maybe SmartPy provides a way to do that too. And as I said, a custom automatically generated crawler, so indexer for your contracts. We can trigger events. For example, maybe you want every time some entry point is called, you want to do something. You can very easily do that with Crawlery. And so, as I said, we're working on integrating dipdub as well, automatically generating a dipdub configuration file from a contract. We're also working on generating a web interface with the state of the storage and all operations, and some forms for interacting with entry points. So it's basically a generic dApp that you will have. Of course, a very coarse dApp that you will want to refine before you write the final product. But from any Mikkelsen file, you can already have something that looks like a dApp that you can visualize what's going on. And we also want to facilitate writing portable scenarios. So with a DSL for scenarios, we're working on that. And then, in the end, we would like to do some amount of static analysis of contracts. So once again, Functori takes Mikkelsen files. So we're talking about static analysis from the Mikkelsen files. And that's it for this presentation. I wanted to leave some time for any questions that you might have about Functori. And otherwise, we have a stand upstairs. Anytime you want to come for a demonstration, or if you have any more elaborate questions, feel free to come by. But I can take some questions now. Yes?
When you generate to a kernel, can we also generate to RaisonML syntax, or only OCaml
No,
syntax?
it's the OCaml syntax. Okay. I guess we could add the RaisonML syntax if there's a need for that. Yes, it wouldn't be too hard.
Okay, thanks.
Well, in any case, we're eager to get new users for Functori, so feel free to reach out, and I'll take the time to help you set up, and well, thank you again.
Yeah. Hello, my name is Sergei. I'm from Baking Bed. And today I'm going to tell you about our great product. It's called TezDev. Please, can you raise your hand if you haven't heard about the TezDev? Okay, that's cool. So I will try to focus on you. And this presentation is going to be very high level so that you guys understand what is TezDev, how it works, and then you can dive deeper into the code when you want. Yeah. So when you're developing your dApp, generally what you want to do, you develop the smart contract, you create the website, and you have to use any API to interact with the smart contract and with the blockchain. So what kind of APIs do you have when you choose? You can work directly with the node, but when you work with the node, you don't have many query options. You just get the transactions, and that's it. You can go to the indexer, for example, the TZKT indexer, and use the TZKT API, but there you don't have many aggregation options. You can just get the list of transactions, and that's it. And then you think, okay, what do I have to do? You have to create your custom backend for that and handle all these problems yourself. And TezDev is a ready-to-use solution that does it all for yourself. So generally speaking, TezDev is a framework for creating selective indexer. So when you want to get not the whole blockchain data, but you want only some piece of information that is related to your smart contract, to your dApp, you use the TezDev and get only this. That's why that helps you, TezDev helps you to have small index size and have small indexing time. That's very good to have, because when you deploy your custom indexer, for example, you have to wait to get all the transactions and everything, so it doesn't worth it. So generally, TezDev is a Python framework. It's built on the Python, and we were inspired by the Graph protocol that exists on the Ethereum. And actually, we try to make our product even better, make it more customizable. So we believe that if we would compete with the Graph, we would beat them because our technology is better. You have to try, and you can compare. Yeah. Yeah, we are very passionate about all this tech stuff, and we try to make so that it's very good and easy to use, and yeah. So as I said, TezDev, yeah, it's a ready-to-use solution to build a custom backend, yeah, for your decentralized application. It saves time, it saves your resources, and etc. So just more about the features that TezDev gives you. So it allows you to have another abstraction layer above the Tezos blockchain, so you can start thinking on your dApp application domain and forget about the Tezos specific, blockchain specific things. That helps you to not waste time on these blockchain things and focus on the application side. Also, it generates a GraphQL API for your backend. So it also saves time for you, and you get the SDK to interact with the API, and you have a lot of integrations out of the box. You can get the data from Coinbase, from IPFS, match it all together, and have one API for your application that has all this data. So under the hood, we have user-generated configuration. So it's configuration file where you specify all these details. Okay, I'm going to get the information from TZKT API, from Coinbase. I want pictures from IPFS, and I want to match them in this way. Yeah. And you specify handlers. So what are handlers? Handlers are the functions that help you where you define how you process the data. So this is like kind of ETL model style. Yeah, you get the data from the chain and other sources, and you process it with handlers and store it in the database. And also in the deep configuration files, you define the models, so how you want, what kind of data you want to store in the database, and how you want to like model your database. Yeah, and at the end, all this information is stored in the PostgreSQL. You also can choose a timescale DB database, and then you get generated Hasura Engine GraphQL API, and you just use it. Yeah. So this is generally what I described right now. Yeah, you can just see that you write configuration file. Just initialize the project, define data models, implement handlers, and run your indexer. And it works, stores in database for you all the information in the format that you need, and generate the API for you. OK, in which cases do you need the deep DAP? Actually, in many cases. When you want to build something, when you want to pre-process the data, for example, and if you get the data from the TZKT API and you want to aggregate, calculate some information, some, I don't know, statistics. For example, you want to calculate the price for the time. For example, you have the financial contract in TZKT. We have the DEX. And there you can, for example, to show the graph, we calculate the information for the day for all the transactions for this contract. So you don't get this information from the TZKT API, but you can calculate it with the deep DAP and have a backend that has all this beautiful, can give you this all beautiful statistics for your smart contracts. Also, you can do some complex domains, multiple tables with relationships, to flexible application design when you need sorting with some fields from your smart contract. Yeah. For example, you have a lot of when you have some DAP-specific variables, and you want to have filters with these variables, you use deep DAP, you get them and index on the deep DAP side, store in the database, and then you can work with them like with any data model. Yeah. And you can join information with the deep DAP. You don't have anything stored in the blockchain. You have a lot of site information, so you can join it with the deep DAP. You can have the cron. We have built-in cron jobs to do some pre-processing in the background. And generally, you can do any data pipelines that comes to your mind. So it's very application-specific, so you have to think about your use cases, and then if you have any proper data pipelines, you can use it. So deep DAP is actually very famous in our community because it handles like a lot of problems that projects have, like TEA, UVs, Gesture, Variable, etc. Yeah, and many projects, we help people to integrate deep DAP into their projects and make them easier to interact with the Tezos blockchain. And this helps many projects to enter the blockchain ecosystem, the Tezos blockchain ecosystem, and just don't spend so much time and resources on doing that. So that's a general overview. Here we can see the links to all materials. We have a very good guide that can help you to understand how to deploy the application, how to configure it, etc., etc. Also, we have very good docs. So you can go to deepdub.net. We have all the information is stored in the docs, and any questions you can find there. Also, you can join our Discord channel and ask our questions to us directly. We're happy to answer any questions. And thank you very much for having me. I would be great to answer any questions that you have. Yeah.
Is DeepDub compatible or going to be compatible with layer 2 solution?
Which solution, sorry?
Layer 2 protocol on Tezos? Like they presented the other day. J'ai oublié le nom. Rollups. Rollups, yes. Voilà.
Rollups?
Yes. Can you get a transaction from rollups?
Yeah, we have this like in our roadmap. And actually, I'm not sure the state, like technically, on which stage is that, but we have this on our roadmap, definitely. Yeah.
Okay, thanks.
Okay. If you don't have any questions now, feel free to come to our stand above. We will be happy to answer any question there in privately. Yeah. Thank you.